Last time we were discussing for loops, and so here's a nice coding example of a class called investment, which you'll find in the book. And here is where we want to kind of start today. Let me just bring up the present slide. And it gives a good example of how a for loop works. In our investment class, we have 3 instance variables. We have the balance, we have the rate at which the investment increases, and then we have a private instance variable, which is the number of years. When we create the investment, here's the constructor for the investment. We input the initial balance, and then we also put in the rate, which is the interest rate for that investment. We also make sure to initialize years to 0. So we want to start counting at 0 rather than 1. Next, we create a method called wait for balance. And it's here where we're looking for a target balance. Say we put in $10,000 and we want to know how many years it will take for that $10,000 to grow into $100,000. This will implement that using a while loop. And the condition for the while loop is while the balance is less than the target balance, then just keep looping. If it is less than the target balance, which it should be the first time you run through it, you add 1 to years, you do the interest rate calculation. It looks like the rate is coming in as a percentage, so you have to divide that by 100 or otherwise it'll blow up on you. So if they put in 5, what they really mean is 5%, so you have to divide that by 100, so that's what's going on here. You multiply that times the balance to get the interest, and then you add the interest to the balance. And you keep doing that until the balance is greater than or equal to the target balance. And since years is an instance variable, that'll be remembered after this method is complete. And so in years, you should have an answer to the question of how many years it'll take to get to that balance. Here's another example. Here's a wait for balance. And then here's another one called wait for years. In this case, wait for balance is a good example of when to use a while loop. You're really not sure when this loop is going to end. You don't really know how many times this is going to go around. So since you don't know that, it's best to use a while loop because you don't have that understanding about, okay, I'm not sure how long this is going to be because really I don't even know what the target balances they're going to be asking for. We might go around twice, we might go around 50 times, who knows. So a while loop is better, but when you know, like in this one, wait years, basically what this method is answering, what questioning is answering is after 10 years, how much money will I have given this interest rate and this balance. So we know how many times we're going to go around the loop because we know the number of years. So it's best then to use a for loop. Here we're starting out at 1, and then we're saying, so that's our counter. And then while I is less than or equal to the number of years, say they say 10 years. So we want to go from 1 year to 10 years. And then at the bottom of the loop we add 1. So we do the same interest calculation. And then what we do is a little bit missing on the bottom there. I wish we could see the whole thing. Let me escape here. Yeah, and so here at the bottom, we add n to the number of years. So say year started out at 0. Here, whatever n is, I'm looking for where n is being defined. Yeah, they don't really say, do they? So I think this is the mistake. This is a mistake in the slide. I think what they mean is they want to add I instead of n. So that should really say I. But what's going on here then is it will add those number of years and tell you how many years it will take to get to that, or how much money you'll have at the end of a certain number of years. So I'm a little confused about this here, why this line of code is here. I'm trying to think if it's necessary. My guess is that it is not, so you can leave that line out. And then here is two accessor methods. One's to get the balance. So you get this, you go and get the balance. Say you say wait years and you want to see what the balance is after that many years. Or maybe you you called wait for balance and you want to figure out the number of years. Well, then you would call wait for balance and then call get years to see how many years it took you to get there. So yeah, I think this is just an erroneous line of code. Let's see how they call it in their test program. So here's the investment runner. There's the main method. It starts out at $10,000, 5% interest rate. We set years to 20. These are all constants. We set up our new investment, initial balance of $10,000 at a rate of 5%, and then we say wait 5 years, and then we go and get the balance, and it tells us what the balance is. And it uses these formatting characters, and I'd really like to learn what these do. So maybe in an upcoming lecture we'll learn how to use formatting characters like these here. It'll make our output look a lot better, our numbers. You get a number here that has just 2 decimal points, or decimal places after the decimal point. So we'll learn about that. But that's basically how you run it. So this is a good example of when to use a while loop and when to use a for loop. And that's all in the book. I'm not going to make you type this in, but I just wanted you to take a look at it so you could see that difference. Now there's some self-test or self-check questions here. So you rewrite the for loop for wait years method as a while loop. Okay, so remember I said in past lectures that a for loop is just a condensed form of a while loop. So anything you can do with a for loop, you can do with a while loop. It's not true the other way around, but what would this look like as a while loop? Well, first you'd have to initialize to I to 1, and then you say while I is less than or equal to n, you do the interest calculation, and then at the bottom of the loop you'd add 1 to I. So that basically is functionally the same as the for loop. It's just expressed here as a while loop. Here's another self-check. How many times does the following loop execute? Well, we start at 0. We go from 0. We start out with I equals 0, and then we loop while I is less than or equal to 10, and then we add 1 to I. And then we print out the square of I, so I is going to get squared each time through the loop. The question is, how many times does the loop execute? Well, you have to be really careful here because we're starting out at 0, but we're not saying less than here, we're saying less than or equal to 10. So if you count I, well, I will have the value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you count how many numbers that is, that's actually 11 numbers. So what you get is 11 times through the loop. It's probably not what you wanted. So typically there's 2 ways to fix this off by one problem. What I would normally do is just take off the equal sign, and that would get you from 0 to 9, which is 10 things. Or you could, instead of starting out at 0, start out at 1. Most novice programmers like starting counting at 1, and so they go from 1. If you do say 1 here, you want to say less than or equal to here. If you do say 0 here, you want to say less than here. Either way, you're going to go around the loop 10 times. Here's some examples of for loops, and it basically gives us some experience looking at what this will do. Here we're going from 0 to 5. What will the value of I be when we go around this loop? Well, we're going to go around this loop just like the last example 6 times. 0, 1, 2, 3, 4, 5. Note that the loop is executed 6 times. Here's another one. We start I equals 5. We say while I is greater than or equal to 0, and we subtract 1 from I each time around. How many times are we going to go around? Again, we're going to go around 6 times because we're including 0. So 5, 4, 3, 2, 1, 0. And we use the decrement operator, or the decrement operator to subtract 1 from I each time. This third example, I equals 0, while I is less than 9, I equals I plus 2. So we're adding 2 to I each time. So we're going to get 0, 2, 4, 6, 8. As soon as we add 2 to 8, we're going to get 10, and that's not less than 9. So we have a step size of 2, so we'll go 0, 2, 4, 6, 8, but no 10. This one's really sneaky because this causes problems. You typically, in conditions for loops, you never use not equal to. You always want to use less than or equal to, greater than or equal to, but not equal to, because what happens here is because our step increases by 2, I is never going to be equal to 9, so this will go on forever. The numbers will go 0, 2, 4, 6, 8, 10. Well, 10 is not equal to 9, nor is 12, nor is 14, and so it goes on and on and on. Unfortunately, you have an infinite loop. So again, stay away from not equal to as a condition inside of as the operator inside of a condition of a for loop. Here's another one where we say I starts out at 1, while I is less than or equal to 20. Do some stuff, and then at the bottom we're going to double the size of I. So I starts out as 1, you double it, that's 2, you double again, that's 4, double again, that's 16. Come around again, now I is 32. Well, 32 is not less than or equal to 20, so the numbers we get for I are here. You can specify any rule for modifying I, such as doubling at every step. As long as the change in I is consistent, then you can use a for loop. If the change in I is not consistent, then it's better to use a while loop. Here's one where we're going from maybe we're looping through a string, one character at a time. So we start out at 0 because the positions inside of a string start numbering at 0. And then you say, well, I is less than or equal to string.length, or not equal to. If you did say equal to, then it would actually blow up because you'd go outside of your string when you would step through it. Since strings positions are numbered from 0 to 1 less than the length, you got to make sure not to include a position of str.length. So the way you do that is you say I less than or equal to, or less than, I less than string.length. So you go 0, 1, 2 until you get to the last valid index of this string. In the loop body, use the expression str.char at I to get the ith character. So if you're parsing a string and you're going through one character at a time, this is the proper way to do it. You don't start at 1. You don't say less than or equal to. Strings character positions are 0 relative, which means that they start counting at 0. Because of that, you have to put less than here. If you say less than or equal to, you'll stray outside the boundaries of the string, and then your program will throw an exception and crash. So again, be careful here, especially with strings. Here's some common errors. For example, here, for some reason, they decided to do all their work in Yeah, trying to see exactly here what they're saying. See, there's a missing semicolon right here. So that's a common error. You do need to have 2 semicolons inside of a for loop. This will probably not compile. Here's another example of a semicolon problem, but this time you have 1 semicolon too many. You see this all the time when somebody puts in a while loop or a for loop. They put a semicolon right at the end of the top of the loop, right after the condition, or in this case, right after the end of the for statement. And that actually ends the loop. And so this only happens once. This loops, 10 times, but it doesn't do anything. It just loops 10 times, and then this happens just once, and the sum will be pretty unexciting. I guess, evidently, I think your sum would be, 10. That's not what you would expect. So again, make sure not to put semicolons here. It's one of the few times in Java where you don't put a semicolon at the end of a line. Is at the top of a loop. Otherwise, you get very strange behavior. And this type of bug is really, really hard to find. So be really careful with this one. You can spend days looking for this and tons of code. It's like looking for a needle in a haystack. Very difficult.